Hello everyone, welcome to QS Stack. Today we are going to see two very important metrics for a RAG-based AI agent application. In this video, we are going to understand what are these metrics, how they are calculated, and then we are going to see how we can do it using code with a live demo. So let's jump into the presentation. So let's begin. So consider an example of a food-based app or a food-based AI chatbot. You ask questions to the chatbot and it responds basis its knowledge, the LLM reasoning, and also the additional knowledge that is provided to it in terms of application context. Recall at K and precision at K are standard metrics for evaluating ranked retrieval and recommendation. Basically, whenever you hit an application like a chatbot with a query, it first fetches the relevant documents from the knowledge base, and then it creates a response and gives you back at the output. So it's really important the document which it is fetching should be relevant. If it is fetching the incorrect document from the knowledge base, obviously the answer will not be correct. So recall at K and precision at K are very important matrices that are used to evaluate the retrieval quality. Now let's understand closely what does precision at K stands for. So precision at K measures out of the top K retrieved items or retrieved chunks. Let's say there are only 3 valid chunks or relevant chunks. So the precision becomes 3 out of 5. So precision at K measures the top K items returned, what fractions are actually relevant. So let's say we have returned 5 knowledge chunks, out of which only 3 are relevant. So precision becomes 3 out of 5, that is 60%. Now let's understand what is recall at K. Recall signifies out of all the retrieved information. Recall signifies the relevant chunks retrieved out of total relevant information present in the knowledge base. So recall at K measures all the relevant items that exist. What fraction did we retrieve in top K? So relevant items retrieved in top K upon total relevant items in the knowledge base. So let's say there are total 8 relevant chunks in the knowledge base and only 3 are retrieved. So recall becomes 3 out of 8. Now for this live demo, we are going to take an application, basically a food AI chatbot. We have set few questions. We have provided some knowledge context in the form of some information specific to the restaurant. Let's move on to the demo part. So here we are considering a food-based application. So we have provided this additional knowledge that we are saving in the form of knowledge base. So here this information has text like welcome to Yummy Tales, which is the name of the restaurant. We are open 24 hours every day of the week. Our specialty dishes are jalebi and paneer bhurji. We serve only vegetarian meals. Our menu includes all these items. Every Friday we offer a 20% discount on all food items. So this will become our knowledge base. Then we have also identified the queries that we are going to ask. So these are our questions. What is your specialty? When do you offer discount? Are non-veg meals available? Do you serve jalebi? So here we are also specifying the relevant docs. So let's say what is your specialty? Now to answer this question, the relevant doc is document 1. Let's go back where we have specified the specialty in document 1. So in the relevant doc, we have mentioned doc 1. So like this, we have stated all these questions, along with we have also mentioned what is the relevant doc for this information. So this is the ground truth. This needs to be populated manually by the SME. Now let's track down step by step how we have captured retrieval and how we have captured precision in this. Let me walk you through this RAG application first, and then I will show you where we are capturing these two matrices. You can get this code by clicking on the repo given in the description section. So here we are using Milvus as a knowledge base. First, we are creating Milvus client, which is hosted at this URL. We are creating a collection called Yummy Tales. Here, we are just adding a safety feature. If the collection already exists, we are dropping it and creating a new one. Now, these are the documents. We have already segregated them in chunks of doc0, doc1, doc2, like this. Now for embeddings, we are using all mini LM L6 V2 embeddings. Now we are creating a text from the docs, and then next is we are creating vectors using embeddings.embed accounts, using embeddings.embed documents. In this we are going to provide our documents. Now then we are simply printing the dimensions, then we are going to create the collection. So in Milvus, first we are defining the schema. We have defined the schema like ID, doc ID, text, and vector with these fields. So here for ID, data type is varchar, is primary. So this is the schema that we have defined overall. Now we are going to insert the data. So for data, for doc and vector, data.append in ID, we are updating a unique ID. Then for vector, we are updating simply the vector. For doc ID, we are updating the doc ID. For text, we are updating the same text. Then we are going to insert the collection. Then we are going to create an index, and then we are going to add the index. Now collection loaded successfully. Up till here, what we have done, whatever knowledge base that I showed you in the terms of relevant information, we have created a collection Yummy Tales on Milvus and uploaded all this knowledge base in terms of embeddings in Milvus. Next is the queries that we are going to ask to our agent, to our application, and then it will fetch the retrieved document from the Milvus. Now here for simplicity we are keeping k as 3. Now precision at k, how we are going to calculate it. So here we have created a method precision at the k which takes retrieved docs and the relevant docs and k. Now hits are actually giving the relevant chunks retrieved, which is actually the retrieved intersection of relevant. So this is how we can calculate the relevant chunks retrieved. So precision at the rate k. How we are going to calculate this? We are going to pass retrieved documents, we are going to pass relevant documents, and we are going to pass k, the value of k. Now hits, here we are calculating, first we are converting the retrieved documents into a set to keep only the unique docs. Again we are going to find the intersection of retrieved and the relevant documents. In other words, basically we are going to find the common document IDs, document chunks from retrieved and relevant information. Let's consider an example for query 1. What is your specialty? We have defined doc1 as the relevant document. Now let's say if I'm running this, what is your specialty? What is your specialty? Yeah. So let's say this is, so for this the output is the retrieved doc is doc 1, 0 and 3. Okay, 3 documents are retrieved. So here in this set we will get these 3 docs, doc 0, 1 and 3. Whereas in the relevant we will get only doc 1. So here basically the intersection of both these two is doc 1 only, which is common in relevant and retrieved. Now the precision at k would be 1 by 3. That is 33%. Similarly for recall at the k, how we have done this. So retrieved, again it will contain all the retrieved chunks. Relevant, it will contain all the relevant chunks. Now hits are calculated by the common information in retrieved and relevant to identify all the relevant information or relevant chunks retrieved. So again doc 1, 0 and 3, and here we have doc 1. So the common one is only doc 1, that is 1. So hit, value of hit is 1. Now so let's consider this first question. What is your specialty? For which we have specified the relevant document is 1, which specifically mentions the specialty. We can verify this using Milvus. So here specialty is only mentioned in doc 1, which specifies what are the dishes which are specialty. Now let's see the retrieval. What is your specialty? The output was doc 0, 1, 2 and 3. So here we can consider the retrieved chunk is doc 1, 0 and 3, and relevant is doc 1. So hits are calculated as, first we are converting retrieved into set to avoid any duplicate, to remove any duplicate docs retrieved, and then we are going to find the intersection of relevant and retrieved. So here in retrieved and relevant, the intersection or the common portion is doc 1. So hits will be 1. Now precision is hits by k, so 1 by 3, that is 33%. Now again for the same example, let's consider the recall. So for recall again we are going to calculate the hits by the relevant information retrieved, which is the intersection of retrieved chunks and the relevant chunks. Its value is 1. Now recall is calculated by hits by length of the relevant docs. So here the relevant information is just 1. So here the length of relevant is 1 and hits is 1. So recall becomes 1 by 1, that is 1. So now this is our evaluate function which converts your question into an embedding, and then the Milvus client performs a search for each question and gives you the output fields in the form of doc ID and text. Now in the retrieved IDs, we append document ID, then we calculate precision by the method precision at k we just discussed. Then we calculate recall again by the method recall at k we just discussed. Here we are going to pass retrieved IDs, relevant docs and k. Now we are going to print these values in the command line. Now then this is for updating the feedback scores in LangSmith, so that we can view this in the form of traces as well. Now this is our code execution where we are running all the questions one by one for evaluation. Now let's run this execution. Okay. So to run this, I'm going to use the command python ragevaluation.py, which is the file name. Okay, so execution is complete. Now let's go back and just visualize the traces. So here first it created the embedding dimensions, it created the Milvus collection, inserted 5 documents, it created index, collection loaded successfully. That means the knowledge base has created. Now it is again starting the query, what is your specialty? Retrieve docs, doc 1, 0 and 3. Precision is 33%. Recall is 1. Second is, when do you offer discount? So retrieve docs are 4, 0 and 3, whereas the relevant docs are, let's go back to our query and see. When do you offer discount? Relevant doc is doc 4, just 1. So for this again the precision is 33, recall is 1. Similarly for all these values. So this is how we can calculate precision at k and recall at k. Here we have used k as 3 for simplicity. Let's see these logs here in LangSmith as well. So here are these logs, which each input has this query, the output fetched, the start time, the latency and the feedbacks in terms of precision and recall. So this was about a live code, how we can calculate precision at 3 and recall at 3. So thanks everyone. Thanks for watching this video. If you have any follow-up questions, you can put it in the comment section. I'll try to answer as much as I can. If you want to get the snapshot of the code that I have used, I have also shared the repository link. You can download it from there and can try for yourself. Stay happy and keep learning.